Hello and welcome to our class. In today's class, we are going to learn about some mathematics. It has been some time while doing some mathematics, so today we will be learning about mathematics. As you can see on the whiteboard, we are going to learn about binomial theorem, and it is part of the algebra. So let's start doing it. Let us now begin with our lecture on the binomial theorem that we are going to learn. Let's first have a look on what is binomial theorem. So let's first get it with its history. Now, as you can see, the expression of the form a plus b whole to the power n, a plus b whole to the power n, is called a binomial. This is called a binomial. This is called a binomial. By direct multiplication, it is easy to expand a plus b whole square, a plus b whole cube, etc. The ancient mathematicians knew about the expansion of a plus b to the power n for n 0 to 7. So a plus b to the power 2, a plus b to the power 3, 2, a plus b to the power 7. These were known by the early mathematicians when n is 0 to 7, when n is 0 to 7. So this was known earlier. Around 1660, Blaise Pascal introduced Pascal's triangle for the coefficients in the expansion of 8 plus b to the power n. So around 1660. 1660. Blaise Pascal. Introduced Pascal's triangle for the coefficients in the expansion of a plus b to the power n. A plus b to the power n. And in the same year, he gave the present form of the binomial theorem. So what is binomial theorem? For non-negative integers. So now we are going to learn about binomial theorem. for non-negative integers. What is binomial theorem? Binomial theorem tells us that a plus b to the power n equals to nc0 a to the power n plus nc1 a to the power n minus 1 b to the power 1 b plus nc2 a to the power n minus 2 b to the power 2 plus nc3 a to the power n minus 3 b to the power 3 plus and so on plus ncn minus 1 a bn minus 1 bn minus 1 plus the final term, the last term is ncn b to the power n. This is the last term. This is the first term. So in this way, the binomial theorem a plus b to the power n is expanded for non-negative integers. So we can see that a plus b to the power n has n plus 1 terms. Has n plus 1 terms. In this way, Pascal's triangle can be found out. When n equals to 0, the coefficient is 1. When n equal to 1, the coefficients are 1 and 1. When n equals to 2, the coefficients are 1, 2, and 1. For example, a plus b to the power 2 equals to a square plus 2ab plus b square. Here we see that the coefficient is 1, 2, and 1. So in this way, the Pascal's triangle can be found for a plus b to the power 5. The coefficients are 1, 5, 10, 10, 5, 1. So in this way, the whole Pascal's triangle can be found out. Now look at the pattern. Look at the pattern from this triangle. For n equals to 4, for n equals to 4, the various coefficients are for C0, for C1, for C2, for C3, and for C4. So these are the coefficients. Similarly, for n equals to 7, the coefficients are 7C0, 7C1, to 7C7. So for any number n, the number of coefficients equals to n plus 1, as we can see from here. So now we have found out the binomial theorem for positive integral index. So the theorem says if a and b are real numbers, then for all n, for all n from the set of natural numbers, a plus b to the power n equals to summation r from r to 0 to n NCR a to the power n minus r, b to the power r. So this is the binomial theorem. This is summation. As you can see from NC0, NC1, these are the coefficient to NCN and NCN. And this expansion has been shortened here by using summation from r equals to 0 to r equals to n. So this is the binomial theorem. Now we have some observations in this binomial theorem. The first observation says that a plus b to the power n has n plus 1 terms. The second observation says that we know that NCR equals to NCN minus R. We know this. So we have NC0 equals to NCN and NC1 equals to NCN minus 1 and so on. And so on. So this is the second observation. This says that the coefficients of the terms equidistant from the beginning and the end in a binomial expansion are equal. So here we see the first term from the beginning and the first term from the end are equal. The second term from the beginning and second term from the end are equal. The coefficients are equal. Thus, the coefficients of terms equidistant from the beginning and the end in a binomial expansion are equal. Third observation. This says that the general term in the expansion of a plus b to the power n is the r plus 1 term. R plus 1th term given by T r plus 1 equals to NCR a to the power n minus r, a to the power n minus r, b to the power r. So for first term r plus 1 equals to 1 means r equal to 0. So t first will be NC0 a to the power n minus 0. This would be the first term. So any term t, r plus 1th term, will be equal to NCR a n minus r into b to the power r. So this is the third observation. General term in the expansion of a plus b to the power n is the r plus 1th term given by tr plus 1 equals to ncr a n minus r b to the power r. Now there are three more observations which we will cover. There are three more observations which will be covered in the next video about the middle term. The first one is about the middle term. The second one is about the pth term from the end. And the third observation is about the value of the binomial expansion. So there are three more. There are, apart from these three observations, there are three more observations. Namely 4, 5, and 6, which we will cover in the next video. And then after those observations, there are deductions from these observations. Then we have the summary and then the solved examples. Then we will solve the examples and the problem solving will start. So this was it. Hope you have liked it. and enjoyed our learning about binomial theorem. We will learn more about it and enjoy further our learning. So this was it. Hope you liked it. Thanks you very much for watching this. Give it a like and share it to the people who are interested in binomial theorem and mathematics and learning. And thanks for watching. Have a great day. Thank you.